Hey everybody, it's Nate and Steph from EXPLORIST.life. We teach people how to build DIY campers. Welcome back to episode number 25 in our Ford Transit DIY camper van build series.
In last week's episode, we installed solar on our roof rack, and in this week's episode, we're gonna be installing floors and L-track in the van. So let's get started.
To get this project started, I immediately hopped into my CAD program, or Cardboard Aided Design program, and started making a template. We'd been gathering cardboard for a few weeks at this point and had some nice big pieces from our pneumatic air conditioner and rich solar panels that would set the base of this template. Now, I like to cover the big areas first and then work my way out to the small detail areas last. I simply use some Gorilla Tape to tape the pieces of cardboard together, and just a tip here, but start with a full roll so you're not being stingy with the tape. Once the template is made, we need to remove the template from the van, and it's very, very important that the template stay as close to true size and shape as possible. Now, there are loads of videos on YouTube about scribing small corners and such, and I'm not going to try to teach any of that in this video, partially because I'm not particularly good at it, but if you need some pointers, look up videos on scribing cabinets, baseboards, or crown molding to get you pointed in the right direction. Now, I like using a scribing compass and a straight edge to make these detailed parts of the templates nice and tight. One of the positives of using cardboard here is if you mess it up, you can just cut it out, redo it, and retape it back in place once it fits. For the floor, we are using Zip System R-Sheathing, which is basically a half-inch piece of OSB that has been mixed with resin, making it water resistive, which is laminated to a piece of 1-inch polyiso foam rated at R6.6. Now, this is the same stuff that people use as the exterior sheathing on their houses up here in the mountains in Colorado. Now, I've seen it used on houses for years and always thought it would make a good van floor. And then we saw a VC rig using it and knew that we had to give it a shot. To fasten the three pieces of wood together, I half-lapped the joints, which means that I took 2 inches off of the wood and 2 inches off of the foam, and then overlapped the joint so that the wood of one panel was sitting on the insulation of the adjacent panel. These would eventually get glued together. Once the three pieces had their joints prepared, I laid the template on top and taped it down and started to trace the edges. I traced a bit outside of the template as it's always easier to remove material than it is to add it back. We cut all of the exterior straight edges with a circular saw and straight edge, and then cut all the details and corners with a jigsaw. Once the floor was cut to shape, it was time to set it aside for a bit and work on flattening out the van floor. There are little ridges and grooves in the van floor. Some are 1.5 inches apart and some are more. Some are far enough apart that we wanted to fill the gaps so the floor was nice and solid when we walked on it. But in the true EXPLORIST.life fashion of something worth doing is worth overdoing, we decided to fill literally all the gaps. For this, we use strips of polyiso foam cut to width. Using a saw blade is kind of messy, and using a handheld box knife was resulting in less than straight cuts. So what did we do? Well, we gave OSHA the finger and lodged a razor blade into our table saw, set up a fence, and slid them through. Definitely had to pay attention to where the blade was in relation to my fingers, but this actually worked really, really well to cut all the foam to uniform widths. I also tried the hot knife here, but it was slower than I wanted. The gaps in the van floor were a bit under a 1/2 inch deep, so my 1/2 inch foam was a bit too tall. To trim these down to size, I got my hot knife and attached the wire attachment, shimmed up the knife on some washers to take off the proper amount, and slid all of the foam through. Now, this actually took several hours, and during the time I was definitely regretting the tediousness, but now that it's all done, I'm glad I took the time because it definitely feels like it was done right. Now, how much R value did these floor strips actually add to the insulation value of the floor? Well, we can take the total floor area divided by the square feet and then multiply that by the insulational coefficient of the polyiso hypotenuse for the rate. Actually, the real answer is...
Don't care, couldn't care less. Goodbye.
We were just using these as spacers to make the floor more sturdy. It's waterproof and adds a bit of extra insulation, sure, but that really wasn't the goal. Maybe some of the insulation nerds watching this video can calculate it all out for me. Once the strips were put into place, Steph came in for doing the honors of trimming off the ends of the foam spacers. Next would have been the time to add the PEX tubing throughout the floor for in-floor heating. And after mocking up a bit of a test piece to make sure that our plan would work, we actually determined that it wasn't going to work as well as we hoped, for a few reasons. Number one, the wood floor did not spread the heat around its surface to be effective enough to distribute the heat from the pipe. Number two, we were opting for some super thin marine fabric flooring, which was not thick enough to fully conceal the tubing. And number three, it was going to take significant work with a router to inlay all of the pipes, which I felt would have decreased the structural integrity of the floor quite a bit. For these reasons, we had to make the decision to scrap the idea of in-floor heating for this build, which it's okay though, we still will have heating, so just stay tuned there. Next was time to move on to the L-track. We planned out where we were going to put in the L-track and made our cut marks. We cut the L-track to length, drilled the holes with a hole saw in either end for the end caps, and then cut the grooves with a circular saw and pulled out the scrap wood. The last step before putting the floor into the van was to cut our flooring to approximate size. Now we're using Cell-Rite cloth flooring, which is a bit of a plasticky, waterproof fabric that seems super durable. We tested out a scrap piece by scratching it with a screwdriver and even spilling some hot sauce on it, and all four of us here in the shop were happy with its performance, and it looks pretty great, which is also important. Next, we placed the R-Sheathing floor into the van. We put glue on top of all the polyiso foam spacers so that the R-Sheathing floor wouldn't slide around once it was installed, and we also glued the pieces of the R-Sheathing together at this point. We let that sit overnight so the glue could cure and we wouldn't have any weird ridges or anything at the joints. The next day we installed the Cell-Rite flooring. We rolled the flooring up and started spreading the glue with a trowel. One bucket of adhesive was plenty for this job, and going a little lighter on the adhesive was preferred, as it does tend to pool up a bit underneath the fabric if too much is used. We worked in 3-foot sections from the front all the way to the back. Once the fabric was laid out, we cut the holes for the L-track and dropped them all into place. Next, we needed to make sure that the fabric was fully stuck to the adhesive. The instructions said to use a 45-pound flooring roller to push the flooring down. Now, we didn't have a 45-pound flooring roller and didn't really want to spend the money to buy a special tool when I am a special tool. Why buy a 45-pound roller when we have a 170-pound Nate and a piece of scrap PVC pipe? It worked pretty well. Next up is securing the L-track through the floor. We wanted this L-track to be as strong as it possibly could be because we're going to be adding a seat or two, and also our cabinets are going to be attached to it, so we are going all the way through the floor of the van with these fasteners. Steph drilled a hole from the top. I deburred from the bottom. Steph vacuumed out the debris. I painted the hole. Steph put the stainless bolt through the L-track. I put on the stainless fender washer and lock nut. Steph tightened the bolt from the top. And I cover the bottom with truck bed liner to prevent rust and leaks. And then we repeated that process about 100 times. The flooring is looking great, but the unfinished edges look like hot garbage, so it's time to tackle all of those and make them look better and also be a bit more durable. For all of our edges, we are going to be using 1/16 inch aluminum angle. Some aluminum C-channel would have been perhaps better here, but I couldn't find any thin, non-structural aluminum in the proper size, so we're making an aluminum angle sandwich. We tackled the rear step of the floor first. I used a digital angle finder to find the angles of the rear step. The rear step is curved too much to simply curve the metal, so we decided to make the rear step in 3 straight edges. I found the angles to be 8 degrees off of straight, so we needed to make 2 relief cuts, each 4 degrees off of 90. I used a jigsaw to make the initial cut, and then a hacksaw to fine-tune the cut, which allowed the angle to flex exactly as planned. And then I did the exact same thing on the other side. Now the aluminum was pretty scratched up from when we bought it and would only get worse as we used it, so we decided to hide the scratches with more scratches, and we hit it with some 220 grit sandpaper, giving the aluminum a brushed look. We cleaned the aluminum off with some alcohol and put it in place for a test fit, and all was good to go. We wanted to simply screw the trim piece down with some 3/4 inch flathead screws, so we needed to countersink these so that they sat nice and flush. So Steph took the necessary measurements and used the drill press to countersink all of the holes where the screws would go. Next we did the exact same thing with the bottom piece of angle, just upside down. This one didn't require countersinking of the screws though, as it's just getting tightly wedged into place with the top piece of channel. We found that the bottom piece of angle was hitting the floor ribs, so I cut 1 inch off of the angle so it would fit better. Now this was a admittedly pretty sketchy cut, and I even felt that this one was a bit dangerous, but it is what it is, so all of you safety nerds can just back off. We've got good insurance here. With the bottom trimmed off, we slid it into place and then put the top piece in place as well, and then screwed the top piece to the floor, which wedged the bottom piece in place. If the bottom piece eventually wiggles free, we'll add some rivets to it. Now I don't suspect that it will, but that's the plan if it needs it. Now if I were better at welding, I would have welded the relief cuts and ground those down to flush, but a bit of sandpaper rounds over the edges so that they aren't sharp, and the back step trim piece is finished and looking admittedly better than expected. We moved on to the side step next, which we installed in nearly the same fashion as the back step. But we first had to finally make a decision on how wide we wanted our step to actually be. We decided just to make the step half the size as the OEM step, so we still had plenty of space to step, but also support a future kitchen and underfloor storage for a pair of sandals or something like that. We cut the sailrite flooring to expose the wood, and then cut the zip sheathing with a jigsaw and a handsaw where the jigsaw didn't fit. And next was cutting the top and bottom aluminum angle to fit, nearly in the exact same manner as we did on the back step. This time we actually made full miter cuts though with our miter saw and our bandsaw to make the lip. Now this was just a ton of back and forth, just taking measurements on lengths and making sure that the angles were going in the right direction, and it really took me back to my last house remodel, installing baseboards. Once all the pieces were cut, we used our drill press to countersink some screw holes in each piece, and then used our sander to give the aluminum a brushed appearance. Then we cleaned it off, clamped it in place, and screwed it down. Now these two pieces didn't stay together as well as the back one, so these got rivets along the whole front edge to make them nice and sturdy. And finally, we sanded down any sharp edges with a sanding sponge and cleaned it all off with some alcohol. Next up was making the underside of the step nice and pretty and give the corner of the step some added support. For this, we were simply making a bit of a veneer, if you will, with some scrap 1/4 inch and 1/2 inch plywood. I cut a piece of 1/2 inch plywood to fit the back part of the step, and then cut some 1/2 inch plywood to make the protruding parts on the miter saw. I laid these pieces out inside the step to test the fit and mark their placements, and then pulled everything out and then glued and screwed them into place. And that was the structure. Now to make it pretty. For this, we simply glued the same flooring to the wood, and here's a montage of how we did that. To finish up this part, I cut some aluminum C-channel, sanded it to match, and glued it onto the fronts of the step with just some super glue and let it dry. And that's the side step. Pretty tedious, but it turned out fantastically. The front lip was definitely the easiest one here. We wanted to finish the lip for looks, sure, but we wanted to keep liquids from getting under the floor when we spill something up front. So we got some butyl tape and laid it in front of the floor and then peeled off the backing. Then we pressed a piece of 2-inch angle into place, and this was just going to be held down by the butyl tape and the top piece of angle that you'll see next. Then we measured the top piece and made some creative cuts where the B-pillar was interfering. And then we countersunk some holes on our drill press, sanded to finish, and screwed it into place. And that's the front lip, all finished up and as water resistant as it can be. And the last piece of the flooring project is to make sure that we can access the mechanism that lowers our spare tire. We made a mark on the floor ahead of time so we knew where to drill, and then used a hole saw to make our initial hole. Running the hole saw in reverse is key here to making sure that it doesn't mess up the carpet or skip out of the hole. Once the hole saw was through the top layer of wood and into the insulation, I took the bit out of the middle of the hole saw so that the teeth of the saw could get all the way down through the insulation without poking a hole in the bottom of the van floor. For the cover, we are using a marine deck plate, and it simply drops into place and screws down with a couple of screws. Now we have access to our spare tire lowering mechanism with a nice and clean looking cover. And that's pretty much it. We are super happy with how it turned out. Now, this was not a fast project by any means and took several weeks, but it was great to spend some time on it to come up with a flooring solution that we've been brainstorming for a long time at this point. It looks good, it's incredibly sturdy, it's water resistant, it's flat, and everything else a floor should be. Now we're excited to also have the L-track for solidly attaching the cabinets to, and even putting an extra seat or two for additional passengers. And that pretty much wraps up this project. Our floors and L-track are completely installed, and we're super happy with how they look.
If you're not sure how we got to this point in the build, be sure to tap below for our full playlist.
And if you are all caught up, tap here to watch the next video in the playlist, which is going to be installing insulation. We'll see you next week.